All right, ladies and gentlemen, welcome back. We're going to today be talking in our third lesson for physics, talking about a really, really important concept. It's actually going to follow you all the way through grade 11 and grade 12 in all of your science classes, except maybe bio, because as a biologist, we hate math. But for chemistry and physics, this is something that we're kind of laying the groundwork for that you really need to make sure you understand as we move forward. And it's the idea of what we call significant digits. Sometimes you hear it called significant figures. And the idea of a significant digit in science is that really it shows how well we measured something, or or maybe a better way of saying is how precisely we measured something. Basically, what it's saying is how good was the ruler you were using, or how good was the tape measure you were using, or whatever it happens to be that you were using. Just how precisely can it measure? To what decimal place can it go to? That's really the idea of significant digits. And in science, because a lot of the time the numbers we're working with are really important, we want to make sure that when we state something in science, we want to make sure that what we're stating is only the digits we know for sure, and none of the ones that we're kind of guessing on. And which is a little bit of a weird concept. So to give you the idea, imagine I've got this ruler here, and I measure something, and it's tough because this doesn't really have numbers on it. But if I measure something and it's like there, yeah, I don't know if you guys, let me try that again. It's like there. No, that's not a good one either. I'm going to go back and delete this. There. All right, let's say we've got whatever it is we're trying to measure, it ends up there on my ruler. It's not directly on one of the lines. It's kind of in between. And let's say we're talking about millimeters here. It's in between 2 millimeters. So I don't know if it's like a half a millimeter, or like 0.6 of a millimeter, or like 0.7 or 0.4. I would probably guess it's 0.5, but I don't know that. And so what significant digits do is they allow us a way to say, you know what, I know these particular places for sure. I'm guessing on my last digit, but it's close to this. All right. So as an example, a little bit of a better one, imagine that I have a piece of paper, and the piece of paper in reality is 31.7768909321 centimeters long. All right. And I'm trying to measure this piece of paper, and my ruler only goes to the millimeter place. It only really goes to this digit. So when I pull my ruler up to that piece of paper, I'll go, oh, it's definitely 31 centimeters, but that last digit I'm not 100% sure of. So I'm going to say it's close to 0.8, because 0.77 is closer to 0.8 than 0.7. So the idea of significant digits is the only thing I can really say with certainty is that paper is about 31.8 centimeters long. And it's that last digit that I'm kind of guessing on, but I have a good ballpark for where it is. I wouldn't want to say it's 31 centimeters if my ruler was good enough to measure to this decimal place. But it's these last ones that I really am not sure of, so I don't want to report on them. I only want to report on the most precise thing I can, which with that ruler would be 31.8%. If you're a little bit confused about this, it will make more sense when I go through my PowerPoint, because my PowerPoint talks about precision and what we mean by that. But for now, just trust me, the idea behind it is a significant digit is really just the numbers that we measured and we know for sure. Everything that comes after those numbers, we kind of have to speculate on. All right, and so there are rules as to what a significant digit is and what a significant digit is not. And so we have to be able to figure out how many significant digits we have anytime we're looking at a number. So the PowerPoint walks through like 5 rules for significant digits. I've kind of summarized them here, and I can even summarize them further than that. But the basics of what a significant digit is versus is not is that a significant digit, any number that's not a 0 is considered to be a significant digit. So if I have like the number 1,456 as an example, that number has 4 significant digits in it because it has 4 numbers that are not zeros. All right. We also say that trailing zeros are considered significant. All I mean by a trailing zero is something like this. If I had the number like 78,000, those 3 zeros there count as being significant. So this number technically has 5 significant digits in it right now. All right. We say that trapped zeros are also considered significant. A trapped zero would be something like All right, those two zeros there, they're trapped between two other numbers, so they are considered significant. And it sounds like I'm listing a lot of rules here, or like, I mean, 4 rules. But really, we can sum it all up by saying that the only numbers that are not significant are what we call leading zeros. Leading zeros are anything like this. Actually, that's a fine example. This number here only has one significant digit in it because this is a leading zero. It's a zero at the front of the number. So this only has one. If I had something like that guy there, this has 2 significant digits in it. None of these zeros count. These 5 zeros here, they're all leading zeros. We don't count them, but it has 2 significant digits, which are the non-zero and then a trailing zero. So the best way to sum up significant digits is every number is a significant digit except a leading zero. And then one little example but one other rule that I added to the PowerPoint, but I'm not going to really, I don't have a little slide on it in this one, is that exact numbers can technically have a infinite number of significant digits. And all I mean by an exact number is something like a count. Like if you were to sit there and count the number of students in a class, and you go, oh, there's 40 students in here. There's exactly 40 students. There's not a 0.004 of a student floating around somewhere. It's exactly 40.0000000000000 all the way to an infinite number of decimal places. So technically, a count, which is an exact number, always has a infinite number of significant digits. So do also when we convert units, like a kilometer has exactly 1,000 meters in it. It's 1,000.000000000. You get the idea. Meters in a kilometer. So technically, those also have a infinite number of significant digits. All right. And the reason this becomes important is when we do math in physics, which we have to do a lot, we can only state our answer to have the correct number of significant digits. And so we have to do a lot of rounding in physics to make sure that the number we're presenting is as precise as we know it. All right, so let's go through some examples of how to do that. All right, so let's talk about how to round a number to the correct number of significant digits. All right, so I just want to talk about my rules for rounding, which are everyone's rules for rounding, I guess. Don't know why I claim them or ownership of them, but I did. So let's go through how to round, just for our, so you guys are clear on what I want, all right? So let's say that we want to round all of these numbers that I have on the page, and this is not in your book, but let's say I want to round all of these to have 3 digits, all right? The way we do that is reading from left to right, you want to take the first 3 digits, all right? So if I look at my first example here, 10.329, the first 3 digits are 10.3. So I'm rounding here, and everything that comes to the right of that line, I want to get rid of. Rounding is really easy. All I want to do here is say, okay, I like to draw the little line. I find it helpful for myself visually. And all I want to do is look to the right of that line and see if the number next to the line is higher, or a 5 or higher, or a 4 or lower. If the number is a 5 or higher, we want to round up, meaning we're going to round that 3 to a 4. If that number is less, or a 4 or less, I want to keep it the same. I'm going to keep it as a 10.3. So here, my number next to this line that I just drew is a 2. That's less than 4. So the number I want to write here when I round this is going to be 10.3. Simple. Now I have 3 significant digits. I have the 1, the 0, which is trapped, and then a 3. We'll do another one. Looking at my 1.2149, again, I want to round to 3 digits. My first 3 digits are these guys here, that 1.21. So all I want to do, what am I doing? All I want to do here is I just want to look to the right of that line, and I want to see if it's a 5 or higher. It's not. It's a 4. I know that technically there's a 9 there, and that 9, if we were to round it here, that 9 would make that round up to a 5. But right now, all I care about is this one number. It's less than 5. So even though it's close to a 5, I'm still going to round down here. All right, so my answer when I round this one is going to be 1.21. Had that been a 5 or higher, I would have rounded up. But I really don't care that this 9's here. I only care what number is sitting in this spot. Okay, so we're going to keep it as 1.21. A bit of a trickier problem shows up when I look at my next example here. All right, so I want to round this number here, 2,568,334. I want to round that to have just 3 numbers, all right? Which means that technically I want to round it kind of right there, All right. So the only three numbers I want are the 2, the 5, and the 6. Okay. Now, when I look to the right of the number, there's an 8 there, which means I'm going to have to round up. And if I just followed all the same rules I just had, and I'm going to put a different color here so you guys don't make this mistake. If I were just follow those rules, you could just write, okay, it's going to be 257 because that 6 rounds up to a 7. But you'll notice, I hope, that the number 257 is nowhere close to 2,568,334. And when we round, we really want our number to be close to the original number, all right? So I can't just write 257 because it's nowhere close to the same number. And I know what you're thinking right now, like, well, Mr. Barry, if only we had a way to take a big number and condense it down to a smaller number that was easier to write, that would solve this problem for us. If only there was a way. And then you'll have that brilliant brain stroke where you realize that's the whole point of scientific notation. So we learned about scientific notation last week. It's the idea of taking a big number and condensing it down. Yes, 257 is not the same as 2,568,000. But I can take 2,568,000, put it into scientific notation, and then still have an approximate number. So what's going to happen here is because I have this this large number, 2 million something, what I'm going to do is I'm still going to round it here where I drew the line. I'm still going to round this 6 up to a 7 because this is higher than 5. But instead of just writing 257 and being done with it, I'm going to have to use scientific notation here. All right. So I'm going to write 2.57, okay? And just like we learned last week, I move my decimal from here to here. I'm going to switch colors, which means I moved it 1, 2, 3, 4, 5, 6 times. Is that right? Yeah, 6 times. So what I'm going to write as my answer is 2.57 times 10 to the power of 6. Now my number is in the same ballpark as 2 million something, all right? I can't just get rid of any whole number like I was trying to do there when I wrote 257. You can't just get rid of those, right? It's a different number. The 2.57 times 10 to the power of 6, if you put that in your calculator, you'd get 2,570,000, which is way closer to the number that I originally started with than 257. So that's the idea of why we have to use scientific notation, is to prepare us to round large numbers. All right? This next one actually has 2 possible answers to it. All right? So when I round this, again, I want to round so I have just the first 3 significant digits reading from left to right, which here, as I go left to right, all these zeros don't count. None of them are significant. I care about these 3 digits here. So I'm going to round right here. Okay? So there's 2 answers here, and they're both the same thing. It depends kind of how you like to write it. So just to show you here, when I do this, I could get 0.0. How many zeros do I have? 3, 6, 8. I have 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then I have 441. Okay, but the number next to the little rounding line that I drew is a 5, which means that my 1 is going to round up to a 2. So I'm going to get 0.00000042, okay? I don't know if I said enough zeros. This would be a totally correct answer if you were to give it to me on like a test or quiz or anything like that. Totally correct. But there's another way we could do it because that's a big number and it's hard to write stuff like that. It's annoying. So I also could have written 4.42 times 10 to the power of, how many times did I move that decimal? I moved it to here. So I moved it 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So 4.42 times 10 to the power of negative 9. Okay? Both of these would get you full marks on a test. The big thing here that I want you to understand is that this first one, the one that we just did here, if you didn't put this in scientific notation, it would be actually incorrect. If you wrote 257, it would be wrong, flat out. Because it's not the same number. It's not even close to the same number. Here, you can actually put either answer down because these are both technically still the same number. They're still in the same wheelhouse. They're still in the same ballpark, all right? So the idea is when you take a large number and you have to round it to really small number of significant digits, you should use scientific notation. For a small number, like this guy here, it doesn't matter which one you do. It's your choice. The best thing I can tell you is that no matter what, putting a number in scientific notation is never wrong, as long as you make the correct scientific notation. But sometimes leaving a number without scientific notation would be wrong. Like if you did, like I say, 257 here, that would be wrong. Okay? So if you're not sure, when in doubt, use scientific notation, as long as you know how to do scientific notation properly. Yeah. Last example here, and I kind of took up the space I wanted to use for it, so I'm going to just make it a little, just going to turn it green just for different. So this guy here, I want to round this to 3 digits, which means that I want to round it right there. All right. Just like we saw back in this example, this is a large number. I need to cut it down to have the correct number of significant digits. I need to get rid of these whole numbers, which normally we don't like to do. So I'm going to need to turn this one into scientific notation. All right. The number next to my line is a 1, so my 3 is not going to change. So my number here is going to be 1.13. Okay, so I have my decimal here. I'm going to move it 1, 2, 3, 4, 5 times. Okay, so my number in the end here is going to be 1.13 times 10 to the power of 5. Because that's how many times I move my digit. All right. Again, if you didn't use scientific notation, this would be incorrect. You can't just write 113. All right, so now we're going to talk about how we actually use this when we do math. I've said this a few times over the last, like even this lesson and then the significant or the scientific notation lesson. I said you always, when you get your answer in physics, you need to figure out how many significant digits you need. And now that we know what significant digits are and how to round with them, we can now talk about how we figure out the number of significant digits that we need. And there's a couple of rules for this that kind of come with conventions that scientists have developed over the years. So the first one is what we do when we multiply or divide. Anytime you multiply or divide, it doesn't matter which one you're doing, it's the same rule. We always want to round our answer so that it has the lowest number of significant digits from the original numbers, which is a really weird sentence. I've had this in my notes for years, and I've tried to figure out ways to kind of clean up how to say it, but it is true. It's just hard to understand. But as soon as we actually start doing the math on it, it's actually really, really easy. All right, so when I look at this first example here, all you have to do, like normal, is actually just multiply all these numbers together. So just put it in your calculator. I don't care that you show your work. I don't care that you can do this off the top of your head. I care that you can put those 3 numbers in the calculator and multiply them together. And when you do that, you should get 5.680632. Okay, so there's my answer. Perfect. The problem is we want to know, we want to make sure we round this to the right number of significant digits. And the way we check that, if you read that sentence again, is we look at our original numbers and we see which one of them had the fewest significant digits. Whatever that is, that's what we're going to round to. So when I look at my numbers, this guy here has 3 significant digits. This one has 2. This one has 4. So this guy here is my one with the fewest significant digits. So I want to round this to only have 2 significant digits because this one only has 2. Let's say this one was my lowest one. Like let's say this one was, let's say 3 was my lowest. Then I'm going to round this to have 3. But as it is, my original numbers, this one here has the fewest significant digits. So I want this to have that many significant digits. So when I round this at the end, I want to round it here so that I only get 2 significant digits. The number next to the 6 is an 8, so that's going to round upwards. So my final answer here is going to be 5.7. Okay? If we were in class and I was doing written tests and stuff like that, if you get the number of significant digits wrong, you actually lose a half a mark almost every single time. It'd be very rare for you to actually get a mark for that. Okay? So it's a really important thing that we're able to do. That example was not in your book, but the next 3 are. They're on page 7 of your booklet. They're down at the bottom. All right? So we're going to go through these ones together as well. All right, so this next one here, and I'm going to switch colors again just so it's clear which example goes with which. So here we're going to go 3.5 times 0.127. Okay? When I multiply those 2 numbers together, my answer is 0.4445. Okay? Now, I have to, as soon as I get the answer, that's great. The math is easy. I just threw it in my calculator. I didn't do any actual work. But when I look at the number, I have to figure out how many significant digits it should have. Looking back to my original numbers, this guy here only has 2. This one technically has 3 significant digits. So I want to round this to only have 2. All right. This first 0 doesn't count. So my only 2 digits I want to keep here are these guys here, right? So I'm going to be rounding right here, all right? That number next to my line is a 4, and so it's less than 5, and so my 2 numbers are going to stay the same. So my final answer here is going to be 0.44. All right, I have 2 significant digits, which is what the original numbers kind of showed me. This 4 here makes this stay at a 4. If it was a 5 or higher, this would round up. All right, so that's that one. Next, we have a multi-step problem. All right, so now we have this multi-step problem, which means it's really important that we follow order of operations. Otherwise, we're going to mess ourselves up. And you'll see that this multiplication here is in brackets, which means in our calculator, we need to make sure we put it in brackets too. Please make sure you follow order of operations. Nothing will screw you up easier than not. So it's easier just to make sure you actually put it into the calculator exactly the same way that you guys see. Okay, so 56.7 times 1.367 divided by 4,561. When I put that into my calculator, what I get as an answer is, change color, is 0.01693839. Okay. Again, we have to figure out how many significant digits we need, and so when we go back to our original numbers, this one here has 3, this one has 4, this one has 4. So we want to round so we have the fewest number, so in this case it's going to be our 3. So which means I'm going to round the number here, because technically these first 2 zeros are not significant. These 3 are. Okay. When I look at my line, the number next to this 9 is also a 9, so that's going to round up. All right. This is always a weird thing with rounding, and I find it really messes students up, so please make sure you understand this. Technically, I'll switch colors here again. When a 9 rounds up, it turns into a 10. Okay, and a 10 has 2 digits to it. So what that means is that 9 is going to turn into this 0 that I just wrote, okay? And this 6 is going to go up by 1 because that's what a 10 is, all right? So my final answer here is going to be 0.0170. So you see how that 9 turned into the 0, the 6 turned into a 7. I could also write this if I wanted to, because I'm not dealing with a whole number here. I didn't get rid of any whole numbers. I could have easily written this as 1.70 times 10 to the power of -2. Okay, which means I would have had to move the decimal place 2 times. It's up to you guys, which one you prefer. All right, let me just move this thing around a little bit. There we go. Hopefully you guys can see that. All right, so let's do this last example here. I'll do it in blue just to make sure that we're different from before. So this one, we're going 23 divided by 7 times 4,857. And when I throw that in the calculator, I get a pretty big number. I get 15,958.71429. All right. So this is a case now when I want to look at my original numbers and figure out which one had the fewest significant digits. It's really clearly this 7. It only has 1 significant digit in it. This has 2. This has 4. So we have to round this whole thing to just become 1 digit. And the only way we have to do that, because we're getting rid of whole numbers, because technically I'm rounding here. Okay. So the only thing we can do is use scientific notation. Now, this 5 next to my 1 is going to make that 1 turn into a 2. So when I write this, I'm going to write my final answer is going to be 2, no decimal, no extra number, because I only want 1 digit, times 10 to the power of 1, 2, 3, 4 times. So 2 times 10 to the power of 4. That's my final answer. One thing to note is that this times 10 here, none of this counts as a part of our significant digits, all right? The only thing that counts with scientific notation is what came before the time symbol. So I only have 1 number in front of my time symbol. That means I only have 1 significant digit. All right, I want to do this one more example with you guys. This one's not in your books, but I want to talk about it because it's something that I find messes students up, so I want to be really clear and upfront with you about what to do with a question like this one. So this question here, I'm dividing 2 numbers that are in scientific notation, all right? So this here and this here. I put these in brackets because I want you guys to get in that habit. Anytime you have to do math in physics where you multiply or divide or add or subtract anything that's in scientific notation, in your calculator, get in the habit of putting that scientific notation number in brackets, because otherwise what's going to happen is your calculator always follows order of operations. It only does what you tell it to. And so technically you would do a division before you would do the multiplication. And so if you don't have these brackets here, what your calculator is going to go do is 10 divided by, or 10 to the power of 6 divided by 4.5. And then it's going to do this multiplication and then this one. If you put this in brackets, it knows to treat this like one number and this like one number. So anytime you're doing math with something that's in scientific notation, please make sure that you put everything in brackets. It will make your life so much simpler, right? When I put this into my calculator, what I get as an answer is 3,111.1111111. Okay, doesn't matter how many ones I have. And we want to round this to have the correct number of significant digits. So looking back to these numbers here, each one of them has 2 significant digits. I've got this guy and this guy. Remember, we don't care about the times 10. We don't care about the exponent. We only care about what comes in front of our times symbol. Both of these have 2 significant digits, so this needs to have 2 significant digits too. What that means is we're going to round it right there. Okay, oh, sorry, that's actually wrong. We're going to round it right there. Oh, no, never mind. I had it right the first time. We are going to round it there. Okay, and because I'm getting rid of whole numbers, what that means is I'm going to need to use scientific notation. Okay, so what I'm going to have as my final answer is 3.1, and this is what messed me up because the rounding spot and the decimal spot are 2 different things. So I'm rounding there, rounding here. Okay, this is less than 4, or 4 or less, so this is going to stay as a 1. But then I need to move my decimal over, and I ended up moving it 3 times. 1, 2, 3 times. So my final answer here is going to be 3.1 times 10 to the power of 3. Okay? Sorry, I was a little unclear on that, and I hope that makes sense. Please ask me on Tuesday if this messed you up. Okay? That's the idea. I have 2 significant digits in my final answer. I made sure I used brackets in my calculator, so I know that I'm doing the correct thing. So now let's talk about the rules for what we do when we add or subtract. So all those rules we just went through, that's just multiplying and dividing. All right, adding and subtracting, just because scientists like to make your lives difficult, has different rules to it. All right, and so I can't stress this enough. With adding or subtracting, I actually don't care about the number of significant digits. All right, not at all. With adding or subtracting, what I care about is that you get the correct number of decimal places. The other significant digits don't matter. So we just want to make sure we have the right number of decimal places, but only if we're adding or subtracting. All right? Multiplication, division, I care about significant digits. Adding, subtracting, I care about decimal places. That's something that you kind of have to sort through sort of on your own a little bit. So, but it follows the same rule though. Whenever I add or subtract, I always want my answer to have the same number of decimal places as the original number with the fewest decimal places. All right. So let's just quickly go through these examples. The first one I'm going to do is not in your book. Just follow along with me. The other 3 are in your book on page 8. All right. So let's go through these. When I add 1.38 plus 16.1 plus 2.441, when I do all that math, what I get as an answer is 19.921. Now remember, I don't care about number of significant digits. All I care about is the number of decimal places. So when I look at my original numbers, this one has 2 decimal places, this one has 1, this one has 3. So because this is my number with the fewest decimal places, I want this to only have 1 decimal place because this one only had 1 decimal place. All right. So what that means is when I round, I'm going to be rounding here. Okay. Again, I don't care about the number of digits. I care about the number of decimal places. The number to the right of my line is a 2, which means that my 9 that's there is going to stay the same. So my final answer here is going to be 19.9. Okay. It has 3 significant digits, which is great. But more than anything, the important part is it has the correct number of decimal places. All right. So our next one, this one is in your book. It's on page, as I said, 8. 32.567 plus 135.0 plus 1.4567. All right, and when I throw that in the calculator, what I get as a final answer here is 169.0237. Okay. And just like I was saying, we always want around to have the fewest number of decimal places. So when I look at my original numbers, this one has 3 decimal places, this one has 1, this one has 4. So my answer to only have 1 to reflect this guy here. Okay, so when I round, I want to round here. That number next to the line is a 2, so it's going to be less than 5, so my 0 stays the same. So my final answer here is going to be 169.0. Okay, and now again, I don't have the right number of significant digits, but I do have, actually I do have the right number of significant digits in this case. But what I care about is the decimal place. All right, on to our next guy. So I'm going to go 246.24 plus 238.278 plus 98.3. And when I throw that in the calculator, what I get as an answer is 582.818. Okay. Just like before, I looked at my original numbers and I looked to see which one had the fewest decimal places. 2 decimal places, 3 decimal places, only 1. So I'm going to round this to only have 1 decimal place as well. So I'm going to round it right there. Okay. Again, the number next to my line is a 1, so that 8's going to stay the same. And so my final answer here is going to be 582.8. All right, so there we go with the correct number of decimal places. Last one, we're going to go 658.0 plus 23.5478 plus 1,345.29. When I add all that together, I get 2,026. Oops, wrong tool. 2,026.8378. Okay, and these are probably bad examples because we seem to get the same number of significant digits every time. So when I look at my original numbers, the one with the fewest was this guy here. It only has 1 decimal place in it, which means I'm going to round right here. That 8 is going to stay the same because the number next to the line is a 3. And so my final answer is 2,026.8. All right, not too bad. They don't really, what I find students struggle with in this section is the remembering that when you do multiplication or division, you do significant digits. When you're adding or subtracting, you do decimal places. Cool fact for you guys, with adding or subtracting, if you're only adding or subtracting, you never need to use scientific notation because the only thing we're getting rid of is decimal places, so we're never changing what our number is, versus multiplication and division where we sometimes need to use scientific notation because we're getting rid of whole numbers. All right. All right, this one's going to be my last example today because, I've been talking for way too long. This is the longest video we've had so far, but I'd say it's the most common concept or the most important concept we've covered so far. But all I want to do is talk about a multiple step problem where you have to both add or subtract and do multiplication or division. With these ones, the most important rule is to make sure you don't round until the very end. So put everything in your calculator exactly the way you see it, get your answer, and then from there figure out what to do. This is going to follow the exact same rule as multiplication and division. All right, so what I mean is whenever you get your final answer, look at your original numbers, look to see which one had the fewest significant digits. As a hint, it's going to be this guy here. And we're going to round our answer to have that many significant digits. Not decimal places. I don't care about the decimal place thing so much. I just care that you get the right number of significant digits. So in this one, when I look at these numbers, this has 3 significant digits, 2, and then 4. So we want our final answer to have 2 significant digits as well. All right? All right, so when I throw this in my calculator, and do be mindful of the brackets, always follow things exactly the way they're written. Make sure you use brackets as much as you can. They're actually really helpful. But anyway, when I throw this in my calculator, what I get as a final answer is 0.03111 129 16. All right, so there's my answer. I just threw everything in the calculator. As soon as I get this, I go, okay, I know I need to have this be 2 significant digits because, again, this one only has 2 significant digits. So when I look at that, it means I'm going to have to round it here. So my answer is going to be 0.031 because that 1 didn't round up to a 2. Or if you wanted, it would also be correct to go 3.1 times 10 to the negative 2 because you would have moved the decimal 1 2 times. Okay. Either way is fine. Like I said, it's never wrong to put something in scientific notation unless you mess up the scientific notation. That's it for me for today. Sorry this video was a little bit longer, but this is a bigger concept. I really hope you guys are doing well. If you have any questions, please, you can email me if you like. This is a difficult thing to explain over email, though. So it might just be best to hold on to your questions until Tuesday, when I can go through them on our virtual class. All right? Really important concept. What I would do now, and I think I haven't actually written the weekly plan yet, but when I do write it in a few minutes, what you should try and do now is page 7, 8, and 9 of your book. It has a lot of practice with just rounding, with doing the math, and please check your answers against what I posted online. It will be helpful for you guys. Hope you guys are doing really well. I miss you guys. I will see you in virtual class on Tuesday. Have a great day.